Go. Okay.
All right, everyone. I'm going to be leading today's lesson.
Yeah, I'm coming out.
Okay. Oh, thank God.
Sorry for not being
Yeah, I know. I haven't got a pink slip yet.
but we'll just run with it. So,
My mom, excuse me.
I wasn't sure what you wanted, erased or not erased.
no, I know. It's my fault.
No, I'm coming right now.
Okay, so today's lesson is going to be focused on Kepler's laws. The laws of planetary motion. So, you might remember them being mentioned during the documentary on Tuesday and Monday, where it was brought up as one of the ways that you can figure out if general relativity is accurate or not. But in general, for those cases not directly applicable to general relativity, Kepler's laws of motion pretty accurately describe the motion of the planets. So, let's start off by asking you guys a simple question. When you think of the orbits of the planets, what shape comes into your mind?
An oval.
An oval? Yes, that's a good answer. Ovals and circles. Yeah. Someone also knows spoilers for this class. Good to know. So, a lot of the time you think of them as being circles, maybe ovals. But, do any of you know what a comet's orbit looks like?
No.
Well, we're about to find out. While you watch this, let me change the setting again because I'm pretty sure I said it's a low speed just in case. No, bro. While you watch this, I would ask that you guys please make one note or observation of anything you find that is interesting. And then afterwards, I'll call on some people to share what they found.
Is that the sun? I'm confused.
The sun in the center. Yes.
Why is it so small?
Does the sun not move?
For this purpose, no.
Wait, yeah, does the sun not have an orbit?
Not have a what?
Does the sun like not orbit at all? It just sits there?
The sun does orbit, but orbits on the size of the galaxy, so we don't notice.
Oh, no, that's my basket.
No, it's not. It's mine.
Worth shading.
Ain't no way.
The sun actually does give us one tiny little orbit. Yep. Yep. Oh, yeah, good. Yes.
Alright. So from all of that, what are some of the things that you guys noticed?
It's way more narrow.
Yes? Yes? Yeah.
I didn't notice, it's a question.
Huh?
Is he going through the sun or is it just like climbing and throwing it out?
It gets very close to the sun, but it's still probably several 100,000 miles away from it. So it's very close, but then it goes around the sun and slingshots back away.
Some comets don't survive that.
Yeah.
Good observation.
Those are the first ones. Sneakers, you look good today.
While the comet was close to the sun, did anybody notice its behavior change at all?
It's more of it.
Sped up? Yeah. It got faster. How about the shape of the orbit? What would you guys say the shape was?
It was way more narrow.
extended.
That was the 180. It looked like a boomerang.
That's not a word, but I'm just gonna look around.
Ovally?
Any other observations?
It was a 180.
Yeah, it does circle around. So, why do you guys think the comet behaves so differently than the planets that it's passing through?
Not as massive.
Because the comet's so small and comparative that it has not enough mass to keep itself inside of the orbit. Yeah, right, the basic orbit, planets are so small, it just, it has so much momentum, like, you can't.
So we have one person saying that they're different because of how small they are, you're saying they're not actually that different, right? Well,
Like the distance from the sun, like the planets are just, like, the comet is shooting too much directly at the sun, but the planets are all way better than their distance.
that's another thing. So, to answer a few more questions, I would like you guys to do a Google search for path of a comet. From one or two sources, gather a couple of observations, and then we'll share some more while I write those on the board.
I'm just man there operates.
Yes? Path of a comet. So just path of comet or path of a comet or orbit of a comet, some combination of those.
Are we on number 1?
Number one is just some of these observations.
No, well, number
And
two.
Number two is you searching for observations.
I was going to research it.
Yeah.
Mountain View High School teacher Randy Bickle has students with can I go to see them like give them questions as the students were quietly on the ground, which is address. We call them so functions.
Dude.
I've heard the comments from you just so long.
Wait, Landon, let me see it.
It says Magic Brewer on
I have to see that.
Very good. Alright.
Dr. Bush, I get to graduate this semester early.
You do. Congratulations.
Wow, it's amazing.
All right.
I think I'm gonna get that law school. Should I go to the military?
What, you have to read what?
I get to graduate a semester early.
Why?
He's taking two English and two history the same semester.
Semester? Oh.
And that'll be all my classes done.
You see something about the military though?
If I went into the military, I wouldn't be able to walk.
Why?
Is it break Because, no, I wouldn't be able to walk, like graduation.
Oh, yeah,
So I go to
that's-
basic and then I go to my job training.
You going to base, or are you going to military?
The benefits, like,
Yeah, that's why.
you're going to.
4 years.
And my dad's retiring next year. He's gonna be 43 and he'll make 90K a
Just a
year
couple of
from doing
observations
nothing
for
else.
comments, guys, just like one or two, could be from the same site, could be from different
So
sections.
for 4 years, the year I go to college,
Yeah.
I can like be a police officer if I have to read, like get to it, so like fast, and definitely read.
vertebrae.
Operate.
You have to like find two sources and write
Yeah, so, because it's a multiple choice test.
Yes.
All right, does everyone have something for number 2?
Not yet.
Not yet?
Oh, hold on, I'm almost done.
Almost done.
And then,
Couple more minutes. I just use the phrasing path of the comment because it's very on topic.
Yeah. Get this last way. I think it's really don't just.
Yo, Mason. Mason.
What?
Want these?
I'm right, this guy that represent.
Anyone want these?
I'll have this water.
They're always posted about it, but I don't want it that.
My mom. On iPad?
Hey, Jaden.
Yeah, I know I work there, but like,
So just make yourself.
I just walk back there and be like,
Yeah, we don't carry.
I mean, I do, but I guess I can move over.
Dr. Blake, by chance, do you have a,
Well, we don't need it right now.
Oh, okay. Alright, never mind.
Okay.
Do you have one?
All right. So, anybody find anything interesting about the comets and their orbits, paths, whatever, what have you?
Closer they are to the sun, faster
The closer they are, the faster. Well, we kind of said that, but I'll just say it again.
Wow, Chris. I got one.
Go ahead.
When a star passes the solar system, it pushes a comet from the Kuiper belt or something like that.
Kepler.
Whatever. And like it pushes the comets toward us.
Okay. So why do you think it's so easy for them to be displaced like that?
What?
Why do you, what would you say is the reason that it's so easy for them to be pushed into a new orbit?
Because they're like, they have no gravitational orbit, just like floating.
They're neutrally floating pretty far out there, but they still have an orbit, just not one that we ever see because of how far away they are.
Oh.
But they're pushed into a new orbit, and it's pretty easy for them to be pushed into a new orbit, but you said it was because they're very small, right?
Yeah.
So if they're small, they're very light, gravity affects them more strongly, even from the same force. Yes.
I said that comets go around the sun in a highly elliptical orbit.
Highly elliptical.
Thanks.
We'll be going over what ellipses actually are in just a moment, but in short, they're basically just really big and very specific kinds of ovals. One more. Anyone? How about you in the hat? You have that.
Travis!
My phone is low, so.
Sure.
What if Google doesn't work out?
Could be just something that you observed from the video first.
Someone wasn't watching the video.
I was. It's just everything I was gonna say was said. Like they move in ours, they move fast after this.
One thing that wasn't said was, did you guys notice how in the video, it has a very vertical orbit compared to everything else around it? Like all of the planets seem to be in the same horizontal plane, but but when you look at the comet, it's not horizontal at all. It's much more at a vertical angle. So that's another thing about comets. The reason the planets all orbit horizontally is kind of complex, but it can basically be simplified to while they were forming, all the stuff that they were forming was already in that plane. So we'll keep it at that. Anyway, all of these observations suggest that comets behave somewhat differently from the planets, but in actuality, they behave by the exact same rules. Those being Kepler's laws of planetary motion, which is what we're primarily talking about today. So, Kepler's laws are made off of the backs of how gravity works, and they explain the motion of all objects that orbit other objects throughout both our solar system and other systems. So, let's start with Kepler's first law. This one's nice and simple. All orbits around the sun in the solar system are ellipses. An ellipses is just a very simple oval that happens to have a special property where these two focus points allow you to make the shape of the oval by drawing two different lines that go to the same point. To show an example of that, here's how you can physically draw an ellipse using a bit of string and some tape. So you start like this, and you go along the edge of the string, that there, flip it, this again, stay in place, stay in place.
Oh no.
You get the idea.
I put some tape up there. I did. If you wanna use new tape, but you don't have to. Yeah.
But you get the idea. You draw using that particular method to get yourself an ellipse. Sorry, Dr. Blake, no chance for you to sneak a smiley face on screen.
Oh, I was looking forward to that.
Yeah. To give a slightly more in-depth explanation of how this works. So, say I draw a line to a particular point on the shape like that. If I draw another line from the other focus point to that same place, I can say, oh wait, I got labeled. So if I label this one left and this one right, then I can say that the sum of L and R, in other words, I add these two lengths together, they'll always add to the same constant number. So let's see an example of that. Would someone like to come up and draw to another point? Anyone want to draw another point?
Kyler would.
Would you like to grab? Don't worry, it's very simple.
He's got his stop 2 seconds ago.
So,
I just spawned in, just draw one.
all you do
On the very
is
last.
you draw a red line to a single point and then the blue line from here to that same point. So, from this one,
Not that hard.
I'll draw to a point on the oval. Okay, now change its color to blue. And then draw from the other focus to that same point.
Good job,
Alright.
Kyler.
So this is a bit more of an extreme example than the usual one, but that actually works because it still proves my point. That if you add these two new L and R's together, you'll still get the same value as you would for the first pair. That's why you can draw using string like that to make an ellipse. You're basically drawing both pairs of lines together at the same time using the string. So yeah, that's all that an ellipse is. It's just a special oval that has this property that you can find any point on it by adding the lengths of the two focus points. Nothing much more specific than that. So that should answer your first set of questions for those various parts. I'll give you a moment to write those down if you haven't already.
Which parts?
Pretty sure it's just 3.
You weren't on the right page.
Oh, we can just draw that?
Yeah. You still need it?
Yeah.
You can draw any 2 lines as long as they have the same sort of point. Or you can take a picture, that also works.
I,
So Kepler's second law is a little bit more complicated and requires a bit of visual understanding to really get it. So what it says is, as an object orbits the sun, a line drawn from the planet to the sun, well, from the sun to the planet, but either way, will sweep through equal areas of space in equal amounts of time. So what does that mean exactly?
I don't know.
Well, let's just say that this particular focus is the sun. And we'll draw a couple of points on here. So say that the planet starts there. This is point 1. And then it gets to here, point 2, in a certain amount of time. So we say that it travels this amount of distance in this amount of time. So that's one particular setup. Now, let's draw another one. I'm going to let you know. I'm going to deliberately get this wrong to prove a point. Let's say we start with point 3 here, and then it goes to point 4, and we will claim that it goes from those 2 points in the same amount of time again. So what Kepler's law means is if I draw a couple of lines from the sun's spot to each point that it travels to, then the shaded area in here should be equal to any other set of points that took the same amount of time to traverse. So that's one particular triangle. Would someone like to draw the triangle for the other set of points?
I would. Okay.
So draw from
I
the
can't see
sun's
your
point
light track.
specifically. So yeah, so draw from the sun specifically.
Oh, the sun.
From the
Yeah.
sun, Travis, come on.
Oh.
It's copied from another diagram, so sometimes it doesn't interact properly.
Straight line.
Yep.
Straightest line.
Straightest
So can I
line.
go through here?
Uh,
Or does it not matter?
You're just drawing to point 4.
Come on, Travis, lock.
Travis.
Sorry, everybody, I'm using a little.
The 4's down there.
Oh.
No, that's
Yeah,
fine,
I
it's fine.
Not this Travis. It's not that hard.
Come on, you think Kyler did, he's in the bathroom.
Drawing to 4, and go ahead and shade that in. So as you're shading that in, I think you can all tell, those 2 triangles are not equal to each other, not remotely. So we did something wrong here. If we want these 2 triangles to actually be equal to each other, what would we have to do to fix it?
Move the sun.
I suppose you could actually move the sun, but let's assume that moving the sun is not an option for this one. Yes.
Have a longer range of focus.
Longer range of focus.
So the left side look farther out than you are currently.
What?
You just said move the sun again.
Yeah.
That's basically what that means. Alright, so, being more specific, if we move point 4, what can we do to make the 2, move the point 4 closer?
Closer to point 3.
Yeah, you move the point.
No.
All that work.
So, the correct way to fix this would be to draw point 4 a lot closer, so that we say that it still covers the same amount. So if I draw the lines again from the sun, to the new points of the triangle. It's a lot more narrow, and it's easier for us to say that those two areas are probably the same, right?
Yes.
Yeah. So what this law basically means is that for a certain amount of time, you travel a certain amount of distance. And in the case of these elliptical orbits, the closer you are to the sun, the more distance you can cover in the same amount of time compared to further out. So what this results in is, say this has a velocity of v over here. Because this travels more distance in the same amount of time, we can say, for simplicity's sake, that this has a speed of 2v instead. So the simple principle of this law is that the closer you are to the sun, the faster the object is moving through its orbit, and the further you are from the sun, the slower it is moving through its orbit. These two terms right here are Greek terms, maybe?
Probably.
Probably. Anyway, they just refer to the particular points where the speed is maximized, closest to the sun, and furthest from the sun, minimized. So,
You know, they feel you.
Control and this.
But that's fine. Yep, thank you.
that's
Okay,
supposed
I
to
feel
be H
better.
right there.
Yep.
Okay. So, the closest
Exactly.
point,
That's wrong, but we had to do it wrong. You'll do it right there.
we'll say that the closest point is right here, relatively speaking. And then the furthest point is right here. So at those 2 points, speed will be the fastest here, and speed will be the slowest way out here. You actually saw that with the comet in the beginning, because when the comet swept around the bend close to the sun, it sped up really, really fast. But then as it started moving away again, it slowed right down. And as you can imagine, when it's way out at the other end of its orbit, it's going to be moving very slowly. Yes.
Should we draw that one for like number 4?
Yes, I believe so. I'll give you a little bit to answer that set of questions right there, based on what we have here. I believe 4 through 7 is covered by this part. Actually, 4 through 10. Just the next couple of pages. Well, they already covered all the answers.
Cool, all right, excellent.
Once you guys finish some of those questions, we'll quickly move over to a simulator so that you can see this in action a little bit more clearly.
What question are we on now?
We're going from 4 to 11.
Wait, so number 6.
Did we already do 4?
Kind
So because we drew it like this before we fixed it, that means that the left side has a bigger area.
That's right, yeah. And so in this incorrect diagram, they sweep out, this one sweeps out a larger area in the same amount of time that that one sweeps out a larger area, so it's incorrect. If you flip the page, then you'll get to redo the diagram correctly. Yeah. Yeah, so we intentionally had to do it wrong the first time.
This is awesome.
Yeah. That one has, actually,
This area is larger than that area, right? But somewhere in the instructions, it tells you that it swept out that area in the same amount of time as that area, right? So this is wrong. The Kepler second law says it sweeps out equal areas at equal time. These are unequal areas at equal time, so no, it's not possible. And then you flip the page and you do it correctly after that. Huh? So here we go. We got make it. Oh, did you put it?
in that case, this case you're supposed to draw.
So pretend that for the equal areas of the triangle.
Review. We're reviewing this now. The biggest thing we that we end up with is trying back. I wonder if Juan hasn't gotten a review. He's in there like.
Don't worry too much about filling the packet out. It's like, it's just for notes and stuff, you're not actually going to collect the packet. Yes. It is not possible. This is actually one thing is correct.
Yeah.
So there's this triangle. Has more area than this triangle. So it's If we said that this traveled the same amount of time as this, this having a bigger area means that it couldn't have. So, next page you'll see that it would actually draw a before that's closer. That, the resulting triangle is smaller, so that will actually.
That would be anyone else.
Yo, Chris.
Guess what he's doing by the way? He's buying another wallet.
From one to two,
Because
now we know going from here to here.
I mean.
Bro, we're in day time class.
But your dad,
What?
Did your dad say
he
that?
says for the same amount of time.
Yeah, I know, but what?
Whereas over here, in that time, he went
He's
to
actually
so it traveled faster.
When he joined, he was in artillery, and then he went to national housing and found out like 7 years.
Alright. So, to show you guys a little bit of what this looks like in practice more cleanly, I will be trying to run the simulation. Dr. Blake, signs back in again, please. I really wish this thing would stay open longer. It's more convenient.
It's annoying.
Tell us your password, Dr. Blake.
I will not.
Is it 1111?
I'm gonna read his fingers.
It's probably the same password as all of ours.
There you go.
That's definitely
Alright.
Nick Odell.
Whoa! So, this is a fence simulation for Kepler's laws, where I'm just gonna reset it. So, you have this orbit. You can tell it's elliptical because the sun's not directly in the middle. You have this planet moving around the sun, and as you can see, it's split into these different areas. What these divisions mean is that they are different amounts of distance covered in a certain amount of time. So if we say that this is 1 and 2, then this would be 3 and 4, where from 1 to 2 covers this amount of distance in that time. And from 3 to 4, it covers less distance in the same amount of time. So if you set it to play, you can see that in the same time frame, it covers different amounts of area. Notice how it's going slower on the right side, and then as it gets closer to the left, it speeds up. So the last page of your worksheet should have a whole bunch more simulator questions specifically related to this one. You can answer those for a little bit, but don't worry about getting all of them. That's not how it works.
Is this not homework?
We're not collecting this one. This one's for notes. But there will be an exit ticket I'll introduce at the end.
I'm not no card, no card.
You post on Facebook.
What would I post on Facebook? Think of what you just said, and then try to send back to an actual normal person, and then. See if I can find my.
We'll do this for about 5, 6 minutes.
That's what I'm saying, yeah, your timing, like, you might hear me going, wow, there's a bell thing. Yeah, your timing is, I don't think you're good, your timing is good. Your, I wanna tell you, your I'll see you back. Yes. Sure.
My sister.
The simulation won't actually be on Canvas, I don't think. So you can just find it by searching fence simulation.
Did I not put that on Canvas?
I don't think so. But yeah, you can just find it by searching for it manually, fence simulations. It will be the second option that pops up in the physics section. If you don't want to, I can just like change it up here. As an example of how it changes, if we reduce it to just 2 divisions, then you can see it covers each side pretty equally. But as it goes to the left, it speeds up.
Hey Madison,
Down again.
the answer's right in front of you. You just have to find out which one it is.
If you increase the divisions,
Powerless thing. amount of time.
Yep, it's
Hey,
always
Travis,
the same amount of time.
Are you a copy fester?
A what?
A copy fester?
What?
A copy fester.
What's that?
It's Mr. Vogel's term for people who copy.
Me?
Yeah.
No.
Anyway,
So-
to answer your question, yeah, each segment has the same amount of time, but how much
Beckham
distance
is.
it covers depends on how fast it's
Beckham
going.
is. The kid
So
who
when it's further away
I
from
sit
the
in the
sun, it
back,
covers
like
less
all the way by the
distance, so
trays,
area is smaller.
and the kid that sits next to me is a copy fester.
What hour?
Third,
Who sits next to you?
Brigham, Schloppy.
Is like Bradley or anyone in your class?
Yeah, Bradley Dyer.
Oh yeah.
Hold on.
Hey, what's it?
Said hold on. I was charging my. I'm charging my phone.
Okay, that link is on campus. Yeah, Mr. James, I'm sorry, you're right. I did not put the link on campus, so it's there now. Sorry about
You'll be able to,
that.
guys, you'll be able to access it later if you want it. Since I don't see that many people working on the final page anyway, we'll just move back to the capital response.
I'm not. If you can leave me alone.
Don't snitch on me. Actually, you just draw a different one for the form, and then you draw a triangle on the space smaller, so it's equal in
Austin
size.
snitched on me. So this is
Whereas this one is a bigger triangle, you draw a smaller triangle that's roughly equal to the size of this. Yes, real thing. What's that supposed to show is that when you're that far out from the sun,
You snitched on me.
cover less land.
You're on the said that, right?
Yes.
Okay.
Anyway,
Okay, Chris, Nick, please take your seats and work on the last page of the worksheet.
snitch.
well, second to last page now. We're going back to Kepler's law number 3 now. All right. Kepler's third law is pretty simple. It also is the only one that has included math here, so you want to pay attention to this one. So it says that you can determine the amount of time it takes for a planet to orbit the sun, its orbital period, by using that formula regarding the average size of the orbit. What's the average size of the orbit? So, as an example, Earth's average distance from the sun, when you take into account its farthest and closest points, is roughly 93 million miles. To make things simple, physicists decided to take that number and just make a new unit out of it called an astronomical unit. It's something that they use in order to measure relative distance in the size of a solar system. So if you say 1 astronomical unit, that is roughly the amount of distance that you have between the sun and the earth, and you can use that to compare distances. So, as an example, Mercury's distance from the sun is 0.387 astronomical units. So, a little bit over a third of the distance of Earth from the sun. You can use these numbers to calculate how long it takes for the planet or other object to orbit the sun. Using this formula of the period is equal to the size of the orbit. To the three guys, folks, please. So the math here is real simple. Let's use an example. So Saturn's average distance from the sun is a value here, is 9.537. So to find how long it takes for Saturn to orbit the sun, you take that value of 9.537 and raise it to the 3/2, or equivalently, the 3/2 can also be written as 1.5 in your calculator. Either one works.
Isn't that just square rooting it and cubing it?
You can cube it first and then switch it, or you square root it and then cube it. Either way, doesn't matter. The 3/2 just takes both operations and does them at the same time. So, on the second to last page for Kepler's law, go ahead and fill out as many of those as you can while I draw up the exit tickets.
Oh, okay.
What are we on now?
We can use my automatic.
What was the total?
Sorry, I was in yellow by you.
I would've laughed.
Me too.
So, question, does anyone have the answer for Saturn there?
No, I'm getting my automatic power.
Okay.
I don't got it.
Your name's in
29.4. Yo, I don't got it.
29.4, let me check.
Don't just
Yep,
stand there.
that's the correct answer. 29.4. So anyone can write that for their Saturn in
What is it?
29.4.
That's what you can write for Saturn?
Yep, that's its orbital period. In other words, it takes 30 years for Saturn to orbit the sun once.
Wow. Pretty interesting, right?
It's very interesting.
Oh, nice job.
Is it one just one?
Has Mr. Bowman said
Or one times one
He like
times
says
one?
Mr. Sweet.
One.
Mr. Sweet.
It's one. Oh.
Mr. Sweeter said that in this world, in school, they wrote it, they discovered we said, what? He was like, yeah, they
We do.
Wow, that's actually disrespectful.
Yeah.
Mr. Bro was like, yeah, it was quite a while ago.
How old are you guys?
Yeah, he's 63.
I'm pretty sure your son had him in his class.
From Mr. Swigert?
Do we have Mr. Swigert again?
Yes. Bro, he just bought it like a $4,000 TV.
Yeah, he was talking about that, but
It was actually really sick.
Does anyone have any other answers for some of the other numbers?
I remember.
I
How
have
about
two
someone
for,
else?
for Mercury.
Mars.
What about Mars?
Yeah, what about it?
I own it,
Really? Then why isn't it called Travis?
because I'm not like that.
I don't think you own it.
Travis is home.
I grew up on Mars.
You're Elon Musk.
You grew up on my land.
No, I think
Elon
on
Mars.
So which Nicodell, like, when we saw
So that means I own you too then.
Just making sure you guys are doing calculations, right?
Yup.
Which motor would be better for my sky with the yellow
Do you want them?
I didn't know
The whole base is 1.5 power.
Oh, what?
I didn't know pizza places made them.
I didn't need it.
84 years.
Has bro never watched Fast and Furious before?
Yeah, guys, you're not multiplying the numbers by 1.5, you're raising the numbers to the 1.5 power.
That's literally trash.
Number to the 1.5 power.
Needs to be perfect.
So what's the idea here? Don't know I'm supposed to That's right.
Did you go first one? I've always done it.
I've had 5-4.
So we write quick.
Travis felt a little zesty right there.
Shit, it's Brian.
If I may interrupt your guys' calculating. So, I have an exit ticket up on board that I would like you guys to try and answer really quick. It's nice and simple. All I want you guys to do is label the points where the orbit is at its fastest speed, where it's at its slowest speed, and calculate what its orbital period is based on the numbers that are written up there.
I have a question.
Yes.
What's Planet X?
Planet X is a hypothetical planet that some people argue may exist, some people argue it doesn't. It's supposed to be outside the Kuiper. Kuiper. Why do I think Kuiper?
Don't just stand
It's
there.
outside the Kuiper belt at a and supposedly it affects the orbit of the sun.
Sounds like he's going to the league.
Planet X.
What's the point?
What are we supposed
Please label on the diagram where orbit is fastest, where it's slowest, and calculate orbital period using this.
So, okay. So we just like write them in order?
In order, or, just draw them as your hand if you want to, or you can just like. Yes.
Engineering.
Yes.
So labeling them in order file.
Don't worry about it, we're not collecting. If you want to,
We did not.
so just draw like this, label where it'll be fastest speed, where it'll be slowest speed, and
No, I just want you guys to
really
see this.
quickly, you can try to do that calculation on the phone where.
Wow.
If you raise it to the free half, you can also raise it to 1.5. So like
Oh, blue.
Earth's A would be 1. And then you raise that to 1.5. So you, on the calculator, you would put that.
Well, tell me how to do
Guy,
it.
boyfriend.
I think you just label the fastest.
Yes.
Man.
Yeah.
Whichever one it is. Yes. Yes, basically.
Oh, so we have to actually
Yeah, you can work with that. And then you just say where it's fastest and slowest.
I knew what you meant.
Please remember to put names on the exit tickets so I can actually use them.
Thank you.
Oh, what? 15. Closest to the sun is going fast. X. You guys remember Malcolm X? Really? Yes, I know. You guys. Malcolm X.
You have the square root and
What? So confused. Just draw those pictures right there.
Yes.
I think I'm.
Which one did you?
Yeah, I can see the left, too.
Same, so the sun is towards the middle. Which side would you say the sun's closer to? Which is the one on the circle? Okay. So, where is where it's furthest away from the sun, which would usually be on the opposite side.
That's my child.
In this
You're
case,
still a child.
you draw like this so that the other phone is my kid here. So, say if the sun is there, whichever side of the circle is closest to where
I was just jamming before you go.
So, say for,
Start with
I
comedy.
see the sun on the left side and then on
It's
the
$100
right
tax
side.
people.
The point of the circle that is closest to the
He
sun
actually slides
side
1/6 of that.
would be where
Use
the
that one lady
fastest
as
point
like
is.
Oklahoma.
So, right out there. would be the fastest
just gonna drop.
The instructions are up there. In the orbital period.
closest to where that focus point would be right there.
Travis, is your exit ticket done?
Nope.
I have a question.
How about Manson the Nick?
Yes.
Doing it? Yes.
So that's what I'm choosing.
I don't know, that doesn't look like yes done to me.
It's done.
Well, do you have the calculations for the periods?
Yeah, it's right here.
Mr. James?
Not all of them are on that.
Not for that one and.
That one. Well.
614. Doesn't it look like a 2? I guess it's from that
Tell
far
me
back.
why.
Hey, nothing but.
It's just you take
No,
it, take that
no.
number.
She didn't wanna help
Oh yeah,
us.
true.
You take this
No, no,
number
tell her to do that.
and raise it to the 3 halves power.
Yeah, I know. It's her. She doesn't know how to do it.
I said that for whoever needs
It's
to
not
hear.
her. It's 0.00 because on the 18 test they're gonna ask for 3 decimals.
Which one's the sun on planet X?
Oh, I forgot to label.
Be the top one, not the, be the top.
It can be either one, as long as you label it correctly, then it doesn't matter.
Oh, okay.
I drew them in these orientations to test if you are actually paying attention. So if you draw them, if you draw them with a different orientation, but you still label it correctly, then you still got the answer.
Okay.
So this is what
Oh, it is behind it, 200 on that shit.
Yeah. 614.
I do whatever I want.
15,214.
Would you do whatever I want, as long as I ask you politely?
Yeah. I
You should give me on with your secret.
What do you mean by it? I came in the money.
Not your average flight. Try not to get scared of Top Gun scary videos. Actually, it's very easy to watch.
Actual money.
Last couple minutes, if you guys want to finish your exercises, please do. If you are finished, then the last few minutes are all yours.